by saying this is definitely a little bit more complicated, but we got the step process here for you to follow, and you've done this in the past, so try to follow along, do the best you can. All right, so here's the first step. Basically, we're going to graph these and shade them like I was talking about in the other video. So step one is to write the inequality in slope-intercept form. It's not technically slope-intercept form because there's no equal sign, because we're going to have inequalities. So as you can see for the first one, I have this one already in basically slope-intercept form, but with the less than symbol. So we're good. Step one, check on this one. Step two, graph the line. Okay, so we've been working on graphing. The y-intercept, remember, is 0, 3. So we're going to go 0, 1, 2, 3, and we're going to put an ordered pair. Whoops, I screwed that up. Hold on. I'm going to put an ordered pair right there. That's my first ordered pair. And then the slope is, I'm going to write it out, as -2/1. So that's down 2, right 1. So down 2, right 1. Down 2, right 1. Down 2, right 1. So I'm making a bunch of ordered pairs here. Down 2, right 1, using the slope of my line. And I can make a lot of them. Up 2, left 1. Up 2, left 1. Okay? So here we go, all those line up. Now normally we would just graph it, but this says if we have less than or greater than, use a dashed line. If it's or equal to, use a solid line. So since this one is not or equal to, we need to be careful, and when we connect this, we actually have to make a dashed line. Now I'm going to try my best on this video to do that, but basically you just connect them on the line. You guys can use a straight edge here, and you do exactly what we've done in the past, just make a dashed line. Now, what that means is that everything on that line is not a solution. It's like an open circle. Like when you guys do x is greater than 3 on a number line, you would put a 3 here, you would put an open circle, and then you would shade this way. Well, the open circle means we don't include 3, because think about it. Is 3 greater than 3? No, that's not true. But if I would have put or equal to, then we would shade this in, because 3 greater than or equal to 3 is a true statement. So basically it's saying all of the ordered pairs that are literally on the line, when you plug them in, they're not going to work out. Okay? All right, so that's a quick explanation. Now, that's step 2. Now, step 3, keep it nice and simple here. Shade the indicated region. If you look here, I'm going to talk about 2 different regions. Let me switch colors here. For this line, I hope you can see that this would be above the line, and this would be below the line. So step 3 says, we're trying to keep it nice and simple for you. If it says greater than or equal to, we go above, bigger, above, less than, below. Okay, so what is this one right here? This is a less than symbol, so we're going to shade below the line. Okay, now I want to tell you, since this is our notes, is exactly what I would do with you in class if I were there today, is the reason we're shading below is because every single one of these ordered pairs here, let me switch colors, okay? Every ordered pair over here, every ordered pair, and every ordered pair over here, there's lots of them. All of these up here, when I plug it in, it will be a false statement. All of these down here, when I plug it in, will be a true statement. Let me prove my point. So, would you guys agree that right here, let me grab the black one, the origin, would we agree the origin is actually below the line? So look what happens when I plug in the origin. 0 is less than -2 times 0 plus 3. That says 0 is less than 0 plus 3, less than 3. That's a true statement. So this point right there, when I plug it in, is true. That means I shade that point. And every other one over here will be a true statement. Now, as opposed to this point, that's the point 10, 0. If I plug in 10, 0, I get 0 less than -2 times 10 plus 3. If I plug in that point, I get 0 is less than, well, that's -20 plus 3 is -17. This is not a true statement. This is a false statement. So what that means is that point can't be shaded. We shade the other side. So again, following the steps, that's exactly how you do this problem. All right, let's try another one. First of all, it's not in slope-intercept form if we look at the step 1, because we have to divide by 4 to everything. Once we do that, we get y is greater than or equal to 2 over 4, very careful, is 1 over 2x, and then minus 2. Now, one thing I'm going to say right now, let's switch to red. Remember, when you divide by a negative, that you must flip the sign. Now, we didn't do that here, but it sparked my memory, and seeing this big starburst of communication made me remember to say that. So flip the sign. If that was a -4, you definitely have to flip the sign, which we don't here. Okay, so here we go, down 2. We're going to go down 2 to graph this line right here. We graph the line, and we're going to go up 1 over 2. Up 1 over 2, up 1 over 2, down 1, left 2. Down 1, these are not the greatest graphs. It's kind of hard to do. But step 2 says dashed line or solid line. Boom, because of this right there, we are going to do a solid line. So I'm going to do my best to connect that. You should do great with your straight edge, but there's our solid line. All right, and again, we would say this is above. I hope you would say this was above, and this is below. So since it says greater than or equal to, I'm going to take my marker and I'm going to shade above. Okay, you can test the points like we just talked about to verify your answer, but everything above gets shaded. Now here's the deal. Even the point that's on the line is true now. Okay, any points on the line are actually part of your answers, whereas over here the stuff on the line was not part of your answers. All right, let's keep it going. I think we got 2 more. So here's the deal. This one's a little tricky because it isn't in the nice, neat form that we want. Okay, but what we can do is we can add x to both sides. It's not in slope-intercept form, but just be very careful. Now we have -3y. You got to keep the negative with the 3. We have less than or equal to, and I would say x plus 6 on this side. Then we're dividing by -3. Divide by -3. So remember, when you divide by a negative, you need to remember to flip the sign. So that's actually going to be greater than or equal to, and this is -1/3 x minus 2. I'm going to slow down here a second, highlight this, make sure you can do this right here. There's a 1 on top, there's a 3 on the bottom. It doesn't matter if you put the negative on the top or the bottom. Doesn't matter, because your slope will come out the exact same way if you do it the right way. So we're going to go down 2, down 2. Whoops, I'm on the wrong thing. Hold on. So we're going to go down 2. That actually works well for shading. Then we're going to go 1. So this is what I mean by that. 1 over -3, or you can think about this as -1 over 3. Either way, that says go down. I'm sorry, that says go up and go left. This says go down and go right. So down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Or go up 1 over 1, 2, 3. Up 1 over 1, 2, 3. And this is going to be a solid line because it's or equal to. So again, I'll do my best here. Solid line. Ooh, that looks solid. All right. Then, I haven't said any jokes today. Sorry, guys. Can't think of any right now. So -1/3, and then we have to go, oh, well, where do we look? Here's the key. Don't look at the beginning of the problem because we've done stuff and we've flipped stuff. Look at the end of the problem. Okay, look right here. What is that? Is that greater than? Or that's greater than, so we need to shade above the line. So it looks like all of these so far have been greater than, so we've been shading above the line. But if it was less than, we would shade below the line, that's all. Okay, and you want to get nice and tight and close to that line, all of that. Nice dark shading, that's my answer. Okay, then this one here, we got to love this one. What does that say? That says y is 3, remember? If it said this, it would be a line where the y value is always 3. So you go up 1, 2, 3, boom, and everything this way forever and ever, everything this way forever and ever and ever. That's the line y equals 3. But we're not graphing the line y equals 3. We're graphing the inequality y is greater than or equal to 3. Well, greater than means above the line, so here we go, we shade above. And I hope the concept makes sense. Would you agree with everything I'm shading right now? Every ordered pair you see there. Here, let me make some big ones. Let's do that right now. Every ordered pair here, every ordered pair, will they have y values that are greater than or equal to 3? Yes, that'll be happening. Okay, so that makes sense there. All right, I hope that worked and helped you, and good luck on your practice.